really appreciate that you're staying here with me and learning about like penetration testing fundamentals. So let's get started. Um, so let's start, right? So my name is Victor Fernandez. All right. I'm in Guillon. I'm from Spain, but living in the United States. I will be instructor through your journey of learning the fundamentals of penetration testing here today. So I'm very happy here for you all, as I hope you are too. I am currently senior red team analyst with 8 years of experience. Sorry, I'm going to stop. I'm going to put my camera too, so you can actually see me. I apologize for that. All right, you can see me? Yes, right? So what I was saying is, I'm currently red team senior analyst with 8 years of experience, where I perform security assessments, penetration testing on one of the biggest airlines that are in the world. And my niche, as my title can intuit, is about offensive security and hardware and software development. So as part of my hobbies, I like to spend time with my 3 kids and wife, speak or volunteer in cybersecurity conferences like DEF CON, and research and develop hardware and software, as well as like doing some miniature painting and gaming like Warhammer 40K. That's all about me. I'm very happy. So let's dive in. How is this course too? So what we expect with this course, it's an hands-on course so that you will learn offensive security techniques to find, exploit, and report real-world vulnerabilities across on-prem and cloud networks and web applications. The course duration is 10 weeks in 2-hour sessions that can give you 14 CU credits too. So the goal is to master the ethical hacking methodology with reconnaissance, scanning, and enumeration using open source and commercial tools like Nmap or Nessus or Metasploits too. So you will be learning about common exploitation workflows with Metasploit, custom scripting with Python, and manual techniques to safely verify and exploit vulnerabilities too. You also understand how to build your own attacker cybersecurity lab that we will perform to in this course, as well as having an introduction to Linux, Bash scripting, and also Python scripting language. So as another extra that I like to make sure in this fundamental of penetration testing is report writing and of penetration tests, and also the brief project communication with clients too. So this is the agenda from the entire course. As I said, is 10 weeks, where we're going to have the first week as an introduction and networking refresh. So we're going to have, of course, today this course introduction, as well as like a day as a penetration tester, or what is the day today, the day of a penetration tester. We will cover also network refreshing, where we will talk about IP addresses, MAC addresses, the TCP, UDP protocols, as well as other common ports, and also the OC model. In week number 2, what we will be doing was like penetration testing home lab, where we basically are going to focus mainly on creating our own attacker lab environment over VMware or VirtualBox and install Kali Linux. So we will be installing one or both software, building the VM, and also modifying the settings of Kali Linux so we can actually update it without any issues there. For week number 3, we will have like a introduction of Linux. So we will see Linux distribution. We will explore the Linux system, see an overview of the sudo, check file systems, users and privileges, also network commands, files, and also services, and also install and updating tools inside of Kali. We will end it with Bash scripting, so you have a little bit of a knowledge of that too. Week number 4 is a little bit for Python. So we will be covering Python environments, strings, operations, variables, and basic methods, as well as user input. So you can have like a little bit of understanding of like Python scripting or coding. So when you probably see some exploits on at the end of the module, you could understand more or less what these exploits are doing. In week number 5, we have ethical hacker methodology and information gathering. So in this week, in this session, what we'll be covering will be like what is the methodology of penetration testing, as well as passive reconnaissance, target identification, email discovery, use of breach credentials, as well as hunting domains, identification of website technologies, among others. The following week, week number 6, we will be covering recon, enumeration, and vulnerability scanning, where we will use like open source tools in Kali Linux and also commercial tools like Nmap to do enumeration, and also Nessus to do research and vulnerabilities too. If you are interested in going more about vulnerability scanning, we have actually one dedicated course in Kyora IQ that you can go farther understanding on that. We're going to cover just the basics. In week number 7, we ended with like the exploitation, report writing, and we will set up the vulnerable machine that is going to be your capstone projects too. So in this week, we will cover in reverse shells, payloads, and Metasploit, and also manual exploitation, brute force attacks, and credential attacks, and of course the report writing. So we will be covering legal documents, the deliverables on the report writing, and finally, I will help you guys set up the first machine that is going to be the first vulnerable machine. So you are going to be able to start applying the concepts that we will have been covering during the module or during the course, applying to that specific vulnerable machine. So the last 3 weeks are going to be more hands-on for you guys to apply what you learned, and we'll be here to give you support. So in weeks number 9 and 10, we will be covering this resolution of each vulnerable machines. I will be I resolve that machine with you guys. And also one of the things that I like is for the ones that you are going to attend, start once we have the report writing information, so you know how to report writing, start writing the report for those capstone projects. So we're going to, and you can send it to me, or we can cover in on class, so we can see what things are going to be real world scenarios. So you are going to reporting those 3 capstone projects, so you can get better on report writing. And finally, the last 2 weeks, again, like resolution of vulnerable machines. And also, I would like to also use these 3 weeks to be more one-to-one with you guys. So if you have actually any questions about like offensive security, or how to more like a mentor part 2, we have like all the 10 weeks as a mentor. But if you bring some ideas or some concerns in each of the weeks, please let me know, and I will be very happy to be your mentor or answer any other questions too. So that's the agenda. So hardware and software requirements for this course. The required hardware is just a laptop or a desktop with 8 gigabytes of RAM minimum, and around 20 to 40 gigabytes of storage. Again, if you don't have enough free storage in your computer, you can always use an external hard drive or USB stick to allocate that virtual machine on, and you don't have to use that computer space. Another point is having a stable internet connection, because like once we have installed Kali Linux, we're going to need to update and upgrade the different repositories of Kali. So we have to have like the operating system updated. In terms of the required software, everything is free, so you don't have to worry about buying anything. VirtualBox or VMware are basically the 2 main tools to virtualize Kali Linux. So that we will cover next week on how to install it, and finally Kali Linux ISO that you can download it right away. Any questions so far from what I explained today? Feel free to stop me, or if you have any questions. So, okay. So let's get all right, let me see. Okay, so let's start with the first class, and we will start with a small introduction about what is a penetration tester, right? That's what we want to know about a penetration tester. So here's basically a typical day of a penetration testers, how a typical day of a penetration tester looks like. That is basically three repeating processes, like three different phases. One is perform an assessment. Two is write the report, and three, give a debrief. This is a very high level, but let's go and focus a little bit on each of the parts. So when performing the assessment, we are going to start by confirming scope, rules of engagement, in-scope assets, test windows, and safety controls. And then once we started doing that, and when after doing that, we're going to do the reconnaissance of like, if first we're going to do some passive reconnaissance, and then carefully go through more control active checks in order to identify attack paths. Once we validate any weaknesses, what we can do is we provide impact and only proof of concept minimally, so we can capture an evidence like screenshots, logs, or timestamps um, to have it reported later in the report. From start to finish, what we're going to do in any of the assessments is communicate with the client or the point in contact, and pause the assessment if we see any instability on the network or we see something that we can break, right? Because we want to stay in the legal and ethical boundaries all the time. So if we see something that it's kind of sketchy, we are probably going to stop, and we are not going to perform after actions once we identify like a vulnerability and it's exploited. The second part, or the second part is write the report, right? Once we have all these findings like identifying in the assessment, all these findings are documented so they can be actually reactionable. So we write what we found and where it lives, or what is the attack or the place where it is vulnerable, and how also can be abused, as well as the business impact. There's in each item or each vulnerability, we need to include any evidence, like all the evidences that we captured before in a process of the assessment, and also give them the severity, for example, using or CFS score or the OWASP risk rating, so they have like some um, risk rating, so they can prioritize, like the clients are going to prioritize the fixes for each finding. And I said the severity for, of course, like each finding or each asset. Also, if we have used any technique that can be mapped with Mitre, we can actually add that to the report. And of course, we need to write a clear remediation and validation steps so the client can understand, or they can re-replicate um, what we performed and how we can and how they can remediate them. We also need to highlight their quick wins and systemic fixes and any other compensating controls. Like one of the things, like for me personally, I realized too, is that at the beginning, like this was like 8 years ago when I started as a consultant, was more focused on what was wrong. And at the end, uh, in the report also needs to happen, or is to show not only the bad things, but also the things that are good, the things that you identified that made your work a little bit harder. Um, so the client can expect that kind of positive feedback too. The Also, there should be an executive summary in the report that tells like the risk story in plain language. So like higher level executives can understand you, or can understand the language or what is inside of the report. And also like at the end, a technical appendix where the technical teams understands all the reproduction steps or any other software or source code that we have been used in order to make proof of concepts on exploit like systems. And finally, we have to give a debrief, right? So as a consultants or penetration testers, we need to deliver the report or the news to do different audiences, right? Normally, the group of audience that is the person that hire you, normally executives, and also a second group that are the technical people or the application owners or the network or the infrastructure owners. That are the ones that actually understands the details of the application that we assess or the infrastructure that we assess. So um, in these um, in this brief, right, we are going to have these two different audience: technical people and non-technical people or executives. So an executive brief explaining the top risk and also likely impact and prioritize remediation. I think it's good to explain it in that meeting, and also a technical deep dive with the root causes and kill chain paths and hardening guidance for the technical people. So all that information aligned with the owners, like time to remediate or a plan to retest that they want us to do, it's also needed to, right? Um, at the end of that debrief, the client also is going to have report, evidence of package, an evidence packet that is basically all our output from the tools that we have been used, and also a remediation checklist, normally based on the findings that we found. So, and I would like to make sure that everyone understands these. Um, what we want as a goal as a penetration tester when we perform assessment is not just to break things, it's more like measurably, like measure what can be improved and give them the tools and the information to make their security and resilience better, right? If we want just to break things, we can always do capture the flag type of assessments, right, or exercises. But like what we are the the extra providing this information right in the report, giving them a nice communication is what it's important for the organization. Not it's like that you break and you found like 30 new vulnerabilities that nobody and like got it. I mean, don't make me wrong, that is nice, but this is very good. But like assess their network or break things and improve their security and resilience, I think it's the main focus. So now we understand the process of the penetration tester day, or how is the day a penetration tester. Let's dive in, like what kind of assessments this a penetration tester can do. So we have a couple of them here, but there is a little bit more. There's others, but um, one of them is like the external pen test, internal network pen test, web and mobile application penetration application pen test, also wireless assessment or wireless pen test, and physical and social engineer assessment. There's other two that we will cover later. So in terms of like the external pen test or external network penetration test, what the security analyst or the offensive security engineer is going to perform is they're going to evaluate internet-facing assets from an attacker's perspective, so the internet side. So we're going to start with OSINT or like open source intelligence gathering to map domains, IPs, and expose services, and then validate vulnerabilities safely on those services that are exposed on the internet. The goal is to understand what an external, basically, adversary could do without internal access. Looks like there's questions, so you can raise your hand, and I will pop it to me. So if you have any questions, yeah, I can give you the word. Yeah, Constance. Yeah, go ahead.
Yeah, I got a question. So the question I gotta ask is the day in the life of a pen tester, the stuff that you give, is it what is done each day or what is expected of a pen tester? Like as far as doing the assessment, I forgot the second point, and then the debriefing. All of that is
Mhm.
done each day,
No.
or okay.
So, and it's like I didn't put it, but normally, um it's based on type of assessments, right? So these three things that I'm going to back to the slide. So the day as a penetration tester is like how will be normally a day, right? But like you could be or performing the assessment or writing the report or giving a debrief. It's very unless you have like three, four different projects at the same time, you are not going to do that in one day, right? So one particular day you will be performing an assessment that is going to be based on what we're going to cover, like right after this slide, or you will be writing a report, or you will giving debrief to your clients. So it's based on the assessment or type the assessment, how much longer is going to take one process or one step or the other. So for external network pen test, that it's this first one, it's based on hours, right? Like consultants normally take between 20 and 30 hours to do this type of network pen testing. And then you have another 8 hours to write the report, and then 1 hour to do the debrief. So it's like more or less 40 hours are consultant job, right? For doing these. It's not going to be 40 hours of your time. So you're not going to do one pen test in 1 hour and sorry, one assessment in 1 week. Normally it's based on when 2, 3 weeks, because there's times where you have to do research and like that doesn't count. It's basically it's all based on what consultant company you are. I had in my personal experience, I didn't do one every week. I at least have 2, 3, or 4 weeks for doing all the assessment, and then I had my own time to perform uh, like research for one time, or like doing the exploitation another time, and write the report on another time, and doing the debrief on another time. Right? It's more like based on companies too. So following with that, we have another type of assessment that is like internal network pen test. That is basically assessing the organization from the inside, right? So it's like imagine that we assume that the attacker is inside of the network, or maybe in a compromised workstation or a Dropbox that we decided to put in the network. So the attacker basically is going to do is enumerate Active Directory, any shares that we can find in that part of the subnet, and also internal services. And then we will test like lateral movement, privilege escalation, and domain compromise paths, and show how quickly can an internal foothold can be full control of that Active Directory um, infrastructure, or any other um, or any other type of infrastructure. It doesn't need to be an Active Directory. Can be, for example, like um, SDLC infrastructure, or any other one. Then we have web and mobile application penetration testing. So I put these together, but can be separated. Uh, Basically, what we do with these two type of penetration testing or assessments is we're going to assess like the web and mobile applications from authentication and session flush, injection, access controls, and business logic issues. And the reason why I add these two together is because like um, mobile applications are getting more and more being created as like web applications when they rely on microservices. So there is nothing statically in the mobile application. Is everything is talking to a server side. So there is constant communication of data um, running through the wire and provide that information to the mobile application. So that's the reason why I put them together. When we perform these type of assessments, we actually go and follow the OWASP guidance. That is like methodology for web and mobile applications to reproduce impact with evidences. And also precise, we're going to provide also what will be the fixes for the developers to apply to. We will continue with one of my favorites, like that is the wireless pen test. And in these type of penetration testing or assessment, security assessments, what we're going to do is analyze Wi-Fi and all any other radio frequency signals, right? That could be like the guest versus network wireless that some companies they have. Understanding what is the WPA2 or WPA3 enterprise protocols. Um, Check any rogue IPs or how the network act when we create rogue IPs or access points, and check any other misconfigurations that could happen in that wireless network. We also test the encryption and authentication on normally like corporate network wireless networks, as well as the network segmentations. What's happening after I join that wireless network? Can I move to a different subnet? Can I go through different places, or I have isolation too? And also any resilience with on the wireless network. For example, if I create an evil twin attack or a credential harvesting, how the network is acting when I use this type of attacks too. Another assessment that I really like to is and it is more like as a red team perspective, is the physical and social engineering assessments. Um, why? Because like in this case, we're going to test the people, any process or facilities against real world tactics, such for example, batch tailgating, log bypass, phishing, and pretexting. It's more like a physical part where we are trying to get involved and try to get into like a physical location to later apply any other type of assessment against that company, right? So these type of assessments are they have a very strict rules of engagement, because there's a big safety component of the pen testers being in a potential risk, right? Like when we do these type of assessments, um, only probably one or two or maximum three people from that facility understands and knows that we are going to get into a facility. So police or emergency response should be aware that we're going to do that type of assessment. So they are not, they are aware that we are going to perform some illegal actions legally, right? We don't want to get shot. We don't want to get arrested. So we normally have these rules of engagement very pretty much like understandable by every single person when we perform these exercises. So the safety of the person that are performing them, it's are safe, right? And we are going to finally with other type of assessments that are not that common, or now they're getting a little bit more common. And one of them is like the IoT penetration testing. And in these type of IoT or like devices or hardware devices, the security researcher or the security analyst or the person that is in charge of the exercise is going to review firmware and is going to do physical hardware identification or reconnaissance, right? He's going to solder or desolder like electronic components, as well as they are going to assess the network exposure for that IoT device in the corporate network. We have also red team engagements, and these engagements, what they do is simulate a stealthy adversary operation to measure the detection and response to the organization that is being assessed. So imagine like a national state APT or a bad hacker or a group of hackers that or black hat hackers that are inside of your network, or they enter in your network in an illegal way. We're going to simulate that kind of stuff so we can create detections for those actions and then improve the resiliency of them of this or the security posture of the organization. And similar as what I said, there exist these purple team engagements, and there are these type of collaboratory assessments where offense and defense teams or red and blue team work together to actually tune detections or fine tune the detections and also close any gaps that they can find. So, for example, this will be this particular APT is doing XYZ technique. We are going to go through those techniques based on the Mitre attack framework to create detections against that. So if something happened, uh, we are aware that, or we have a detection in place that are going to tell us, hey, there is something wrong in my network, so we can appropriate a playbook against that. Any questions so far? Very good. Okay, so let's continue. Then we have the report writing, right? The second part was the report writing. So let me tell you a little bit of report writing. It's like great reporting is basically half the value of a penetration test. Um, why so? Because like you can have a lot of findings, but if you are not able to explain properly those findings, that assessment, that value is basically zero. So as I said at the beginning, our work is to make others understand what we found. And this is how, and this is why the report writing is that important. As I said, we write to two different audience, the executive people and the technical people. The executive is basically are not technical people, so we're going to have one specific section in the report for them. Uh, that leads with the risk story. Maybe we're going to put the top 3 to 5 findings, what will be the business impact of them, in just literally plain language, so everyone can understand. It's like if is imagine like explain that to your old grandma, right? The likelihood and any prioritized remediation roadmap that you can actually apply to. Include also any heat map or like KPIs that executives like to have, type of metrics. So, for example, like the type of compromise or the path that you follow to gather the keys of the castle, that type of stuff. Like and explain also what are the success, what is the what is going to look like after you made the fixes. In this part, we're not going to dump any tools, just decisions and outcomes. Nothing technical. They don't like that. However, later on, like in the report, we're going to have like the technical section where we're going to have in each finding, we're going to have a document with a description, affected assets, evidence with screenshots, command, timestamps, uh, code if you wrote, reproduction steps, like what is the root cause, the severity based on the CVSS or always risk rating, and also a clear remediation and like any potential links for references that can help like the technical people understand to remediate the finding. So for example, config changes, code fixes, detections to add, for example, and also validation steps for retest. Most of the companies, once you finish your penetration test, they have the ability to let you retest, or they have their own internal team to retest. You have to have those validation steps for retest the other teams, unless you are not going to be the validator after the fixes. And also we have to add any recommendation again to basically both groups, like another extra section when we can uh, um, recommend to those groups what will be the fixes. Um, so like as a recap, for example, like executives get timelines and owners get like budget or time for guidance, and engineers get more like practice actions, references, and test comments. So the goal is simple, right? Make it easy to decide what to fix or what not to fix. Nobody's going to fix your report in 24 or 48 hours, or the SLA, the smallest SLAs that you have in your organization, because it's not feasible. So that's the reason why we give them the report, so they actually can prioritize what is more important for them to fix. And then we finish with the debrief. That the debrief is where we turn findings into actions, right? So we're going to bring executives or directors and technical people and decision makers to the same room or the same meeting. And here is align risk, priorities, and also the next steps that they're going to do. The flow basically is going through the executive summary, like explaining top risk. This is on a conversation. We normally, what we do is we meet on chat on Teams or any other application or in person, and then we go through the executive summary first, showing top risk, business impact, and what will be the your opinion as a consultant prioritized roadmap. Then we go with the technical deep dive on the high impact items. So they understand, the technical people, they can understand the what we exploited and the root cause and how to fix it. If there is, for example, like reports where, like red team engagement, where the SOC has been seeing you or they have been track your actions, we can actually add them in the conversation too, and tell them what they need to fine tune in their detection, so we can recommend more other their actions to make their detections better too. So this is very, very important. What are the super important rules here when we're going to do the debrief? Because sometimes, like, and I've seen this in my career, is there's a lot of people pointing fingers in this type of meetings at the beginning. So there's no blame tribe culture here. Is like the objective is implementing and improving good security controls or improve like the security and learning of the organization. So it's more like a collaborative between all of us, help the organization be more secure. So at that time, for example, like when you are doing this debrief, uh, questions are always welcome. Like you can stop the conversation, and if someone has any question, either technical or not technical, you just stop, and answer any questions. And for example, if there is something sensitive, um, and that not all the audience need to know, just like move on and do it in a follow up with the right audience too. So in that debrief, what you're going to have as an output is a report, of course, an evidence package with all the remediation, all the output from the tools that you have been using, any source code that you have been developing for them, and also a remediation checklist. And if they want you to retest, of course, like any contact info that from your consulting company or from if they want to retest. And if normal, there's all other um, people. If you work in internal teams, like now I'm doing, there's also project management teams involved that they take progress and dates to be tracked. Uh, that are not more in the consultant time. You can still like as an extra track their progress, but I didn't see that very often. Um, and that's part of the debrief. Any questions, comments? Okay, so let's go now with a little bit more of the after this small introduction. Let's refresh about networking. Oh, yeah. Um, Ermias? Yeah, go ahead.
Yeah, thanks for your introduction and everything. You've taken so short time to take us through a whole topic of pen testing. And I want to understand, what's the basic coding level? Do you need any skills of coding on any programming language to be a pen tester? Or what are the basic required skills that you need to have to become a pen tester? Thank you.
Yeah, thank you very much. That's a great question. Um, Minimal knowledge, I will say, having what we're going to cover in this course, right? Having a little bit of a knowledge of networking, how network works, uh, the about operating system, Linux, Windows, and be a little bit fluent in the command line. You don't necessarily need about a lot of programming, but just learning about like just understanding a little bit of scripting or basic understanding of programming is the minimal skills. I will say it's more important to have been open-minded and learn how to solve problems than and be proactive on solving problems rather than have a lot of acknowledge, right? Because like as you are growing in your cybersecurity career or in offensive security career, you are not going to know everything, right? You are going to end up like specializing in something that you like, um, and that is what is going to also give you the chances of learning more of how to solve the problems that you are going to have. Um, that will be um, my answer to your questions. Like being hungry on understanding or how to solve problems, and once you understand how to solve problems or being proactive or learning how to solve problems, the rest of the things are going to come uh, either in one way or the other, right? Um, you are going to encounter situations where you are going to need to learn about programming or scripting. Then you are going to go a little bit understand, like you're going to take a, I don't know, 8-hour course of scripting and coding. Then maybe you don't understand something about why this machine is acting in this way in a specific network, or why this machine has the SSH port in not in the port 22, in the port 2222, because someone decided to change that port. And it's like, oh, so yeah, that will be my answer.
All right, great. That's fine. I understood. Thanks for your answer.
You mentioned the SOC. Is the SOC usually aware of the penetration tests? And if there's a detection, do you just document that and kind of move on to another finding?
So no, necessarily. It all depends. For example, when I talked about uh, red team assessments or red team engagements, normally they don't, or when we do physical assessments, they don't. The only assessments that they are actually or actively involved are in those that are purple team assessment, because basically we work together. In the rest of them, no, definitely they don't. Um, Me as a internal red team, um, when they ask or when they have or find any detections, they ask us, "Hey, are you this? Did you make these actions?" And because like you as a pen tester or as like a security offensive security engineer or analyst, you keep track of every action that you performed at what time. Then is when you can start the conversation with the blue team, saying, "Hey." The blue team normally is going to ask you is like, hey, did you perform XYZ on this host, blah, 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 at XYZ hour? And you're going to check on your logs. Hey, did you do that? Yes or no? And if they catch you, what you're going to do that is later in the report, you're going to note that and says the detection XYZ was triggered because we did ABC, right? So you are learning from that, and you will put it later in the report saying, "Yeah, this is a good thing that they found you doing that type of that action." So that means the maturity of their blue team is it's good, right? It's Excel, basically. Okay. So let's just start with network refreshing. Okay. So the network refreshing. Let's just start with a quick map of the basics that we will start to finish in this course. So we will talk about, we're going to talk about IP addresses. What is,
I see.
and yeah, go ahead.
Francois Moha. Oh, sorry.
Oh, you wanted to say something? Okay, okay, thank you, Constance. So let's think about the IP addresses as like the street addresses for devices. That's so basically data knows um, where to go. For example, in IPv4, looks like you probably have seen this in your computer, but like your house IP address normally in your computer looks like 192.168.1.10 or that 15, right? While IPv6 looks a little bit longer. It's like a lot of blob with F numbers and hexadecimal string, right? And it's basically these IPv6 is designed because we run out of IPv4 IP addresses, right? So we have private ranges like 192.168.x.x that is basically inside of the network. But there are other public IP address that could be 17.7.12.14, right? All based on the external network. Then we have the MAC addresses. So these are hardware IDs burned into network interfaces chips. There are basically 6 pairs of hexadecimal characters like 001122334455, or let's say 001A2B3C4D5E. And normally are basically used in switches because the switches use MACs to deliver the frames on the local network. And so one thing that you should know is that IP addresses can change, while MAC addresses usually doesn't. Or yeah, they usually doesn't unless you change parts of the kernel for privacy. We will cover later this. Then we have the TCP and UDP. They are the two of the main transfer protocols. So TCP is a reliable connection oriented and basically guarantees order delivery. And UDP is a connectionless, where it's faster, lighter, but doesn't guarantee that we received the package from point A to point B or node A to node B. So for it, it's used for streaming, DNS, and also telemetry where speeds like here doesn't matter. It's more like a perfection thing, right? We will be covering also some common ports and protocols like that you should be aware, like SSH port number 22, or like DNS port 53, HTTP or HTTPS. Do you know which one is? You want to type it, or you can raise your hand and tell the port number.
443.
Okay, yeah, that's one. And what about HTTP?
Port 80.
Yep, correct.
Or 88.
Yep. Yeah, this is Nina said something very interesting too. Nina, you said 8080?
Yes, that was me.
Yeah, so it's very interesting because like by default, yeah, HTTP can be it's in port 80, but a lot of web servers allows you to change that port to any port that we want locally. So so if we decided that the protocol is going to travel to port 8080, we can actually make that suitable when we browse, when we go in our browser and say it's HTTP semicolon / or the DNS that we have, and we ended having semicolon 8080. So we are basically telling the browser that a service in port 8080 an HTTP service is running on 8080. So it's actually a good answer to. Not the standard, but can happen too. So knowing normally the typical ports are going to help you troubleshoot or secure and quickly identify services, right? Without needing a lot of like recon tools that are going to provide you a lot of info too. And we will be covering this more in depth, but we will go through the OC model. That is the model for networking. So we have the physical, the data link, the network layer, the transport layer, the session presentation and application, right? And that we will be very much close, like getting detail in the last slide. So let's go through the IP addresses a little bit more in depth, right? So our unique logical address for a device that can be IPv4 or IPv6, as I said. So with IPv4, you will see numbers, like I said, 192.168.1.1.25, or in IPv6 will be something like 2001 DB855 blah, right? So we distinguish two different type of networks, or the space or private space, so two different IP spaces, the private and the public space. The private spaces range are 10.0.0.0.0/8, 172.1.16.0.0.12, and later I will cover what is this -12 in the CIDR notation, but or 192.168.0.0/16. And those are in your network. It's based on how big or how small you want to be your network. You're going to have these IP ranges, right? They're normally translated by net when going through the internet, so they are basically routed globally. Also, the IP addresses can be static or dynamic. When they are static, are basically manually assigned. This is typical common from servers or network gear, and also dynamic, right, via DHCP, the DHCP protocol, where basically a server act when they request an IP address, the DHCP server is checking which IP addresses are available and provide a list to that IP address for that device to have one IP. You often see, and let's go now to the CIDR notation. So sometimes you're going to see like 10.0.1.5/24. D24 basically is the subnet mask, while the first 8 octets are basically the IP for that particular range or group of IPs. We have the idea here is like, instead of giving you the idea here is giving you a range of IP addresses with that notation. For example, like if we do and say 10.0.1.1/8, we're going to have all the class A domain, like class of IP address, while if we have /32, it's a single host, or a 16 that is a larger network. The key idea here is that if the destination is in your subnet by mask, you can send them directly, so you can point-to-point communication. While, for example, if we have 192.168.7.1, that 2.2, and we have 192.168.3.3, they need a router or like a middle piece in your network to basically transfer packets between one each other. So let's go through the MAC address. So here in the MAC address, the MAC address basically live in layer 2 and identify network interfaces on local link. So they are 48 bits that are basically 6 pairs in hexadecimal: AA, BB, CC, DD, EE, and FF. That's the format. The first 24, that is basically the 3 first bytes group of the first octet. It's the OUI, and it usually identifies by the vendor. So, for example, Dell can be a vendor. I think as like Fuji can be another vendor. They basically have different vendors that they own their own MAC address. And the last one is the part that is fixed by NIC, by their NIC, NIC. And normally it's for identifying that specific piece of hardware that is unique. Okay. So Max, you can actually change that second part of the second third octets of the MAC address by software. There's a software in Linux that is called Mac Changer that you need actually like admin credentials to change it, but you can actually change one specific interface MAC address if you want to. So why is these MAC actually important? Because the MAC addresses are going directly related to IP addresses. How? Because when a MAC address, when IP address is given during the DHCP process, that IP address is basically stored in a table with the MAC address associated with it. So everyone knows if we, for example, do an ARP request or with the ARP protocol, that is basically what it does is one particular device ask for who is AABBCCDDEEFF, and it's multicast. They send it to, like, they broadcast to all the network. The device that has the MAC address AABBCCDDEEFF is going to reply, it's me, 192.168.17.3.7, right? So that is like the relationship between what we have with MAC addresses and IPs. So let's go through the TCP, UDP, and the three-way handshake. As I commented at the beginning a little bit, we had that the TCP is reliable and connection-oriented. And basically what it does is keep track of what is arrived and resends what didn't arrive. So the protocol also manage flow or the receiver window and also congestion. So if there's like a very slow link, it automatically slow start and let's say re-request or retransmit if the package has not been arrived properly. So it's like a reliable way to establish a connection. The three-way handshake states establishes states before data flows, right? So first, the SYN packet, SIN, is sent from the client to a server with an initial sequence number, right? 00000001. And then the server, after that, once he received the SYN packet, is replying back to the client saying SYNAC, saying in this SYNAC package. This SYNAC package is basically acknowledging that the client SYN packet arrived to the server. Once this SYNAC actually arrived to the client again, that client sent it back an acknowledged packet saying, hey, server, it's me. I acknowledge your SYNAC. So after this three-way handshake is performed, we know that this connection automatically is being reliable. In the other side, we have UDP, the UDP protocol, right? It's basically what we said is a connectionless and lightweight. So there's no handshake involved, no ordering, no retransmission. It's just burst like packets. So in this case, it makes simple, faster, and but not reliable, right? So when we want to use each of the protocols, for example, we want TCP, we want something reliable, right? Like a website or SSH connections or any file transfer. So we cannot lose bytes in during the transmission. Well, basically everything that needs to be guaranteed in order delivery. And then we have the other P, the UDP, like that can be DNS or voice IP or any gaming where the latency matters and occasional loss is acceptable, right? Because they have their own ways to recreate that packet, or at that point where Do you have the experience when you are, for example, like talking over Teams and you're starting hearing chopping or like several words that are actually not you don't understand, but or do you have that? Because if you have that, that means that some UDP packets are dropped. So, but you can still understanding the conversation, right? Because there is later like some kind of like remanufacturing packets back in the voice IP protocol. But if you experience that, that means that UDP packets has been dropped, so are not being delivered um, in an acceptable way. And we continue with common ports and protocols. As we said, we already covered these before, but these are a little bit of common ports and also services that are on those are interesting for my recommendations. Learn about them, studying the most common, right? For example, like 3389 as RDP, or 3306 for MySQL database, or even the 22 that is for SSH, or even if you see the DNS of it, 53 or 80, right? Those are important ports. So you need to, there's like this rule that is well known that it's like, for example, from the port 0 to 1023, I believe it is, those ports numbers are standardized. From the 1024 to the 49,151, they vary, right? Are basically registered, but they can vary. And the rest of them are ephemeral reports, so you can actually use them as well as you want. So another thing that we talked before is that there's services that can run on non-standard ports. So you need to verify if you see, yeah, that's great. Like 445, the CFS SMB share. Yeah, it's another one. Yeah, great. Source services, as Nina said before, can run on non-standard ports. So it's important to verify when we're going to do any scanning ports in the network, verify with banners or verify that that is particular service is legit what we think it is, right? Because I can, if I want to, I can run SSH import 80 if I'm not running any other HTTP services in the same server. But I can make that happen. Everything is free. It's like, it's the beauty of the computer science. You can do whatever you want with a computer, right? And let's go with the OC model. Okay, this is I put this image from datasunrise.com because pretty much explains very well about the OC model. So we have from the bottom to the top, right? We have physical layer that is basically that layer where transmit the bit stream or the physical medium. Can be a cable, can be wireless, or can be radio frequency, even can be fiber, right? All of that medium. Then we have the data link layer that is basically that defines the format of the data of the network. That can be MAC addresses, right? Then we have the network layer. So decides which typical path the data will take. In this case, are we going to do IPv4? Are we going to do IPv6, right? And then we have the transport layer, how we want to transmit the data from the previous layers. Is it going to be TCP? Are going to be UDP? Are we going to define our own protocol for transport layer, right? There's other protocols that exist that doesn't necessarily need to have, doesn't need to be TCP. There are UDP with reliable communications. Then we have the session layer that basically maintains the connection and is responsible for controlling ports and sessions. So it's like it's crazy what you can do when you understand all of this. We have later like presentation layer that basically ensure that the data is usable format and where is data encryption occurs. Like for example, TLS, no SSL. And then application layer is the human computer interaction layer, where applications can access to the network services. Can be HTTP, TLS, can be also HTTP. And I said the difference between TLS and why I said TLS and as application layer is because TLS can act also as their own application layer instead of being a presentation layer that can be SSL. And this is actually very interesting. I did a couple of research a while ago where I create my own OSI model, right? So I create the physical layer, data link layer, network layer, and transport layer. And then I didn't want to have any session layer because my protocol doesn't need it, or the presentation layer didn't need it. So I saved two or made the last three layers one layer called the application layer with a TLS protocol too. Quite fun, that project. And that's it for today. It's let's see what we learned today. So we have learned the different penetration testing assessments that can be performed by any security analyst, penetration testing, whatever you want to call it, security professional, offensive security professional. We refreshed also acknowledged and networking fundamentals like IP address, MAC addresses, ports and protocols, and the OSI model. And next steps that we are going to do for next week is we're going to get in depth with hands-on on machine virtualization using VMware and VirtualBox, and we're going to learn how to install, build, and set up like a Kali Linux machine on your computer. So if you have any questions, here's my email from Kyora IQ. So feel free to send me any possible questions, and I will post it now also in the chat so you can have it. KyoraIQ.com. And if you have any questions, thank you very much for your time, and go ahead and give me any shoot me any questions that you need. I hope you enjoyed today as well as I did. Thank you guys.